Hey, good morning. Is everyone awake yet? Getting there? Yeah. People are still trickling in. I'll give you guys a couple minutes to just wander in. In the meantime, I'm going to give you a little preview of what I'm going to be talking about, because I'm going to be talking about dependency injection. And the reason I talk about dependency injection is because it was hard for me to learn. Because like most people, basically the way we're introduced to dependency injection is, here's an application that has a DI container already in it, good luck. And the really bad thing about DI containers is they're magical. And the really good thing about DI containers is that they're magical. So what I'm going to do today is dispel some of that magic. So we're going to look at some of the concepts behind dependency injection, why we want to use it, how it's important, and then we're going to discover that it's not quite as complicated as it seems when we first run up to it. And so by the time we hit the end, we'll get rid of some of that magic that the DI containers have, and so that we can use them more effectively. Does that sound good? Yeah, good. Well, you're in the right room. Now, just as a warning, I am going to be showing a lot of code. I love code. That's how I think. So I am a .NET developer primarily, so I'm going to be showing C# code. Don't let that scare you. Basically, if you have any curly brace language experience and you can do some OO, you will follow along the code I'm showing today just fine. If you want to find slides, code samples, all that other cool stuff, head out to my website, jeremybytes.com. And there's articles and walkthroughs and all kinds of other fun stuff. Another thing is I am also a Pluralsight author. If you're not familiar with Pluralsight, really cool online training. And I have a course, Dependency Injection On-Ramp. For those of you who have seen that course, you will see nothing new in this talk today. However, I am much more entertaining in person, so I would recommend that you stick around. Twitter, Jeremy Bytes. So tweet awesome things about me, because I love to see myself on Twitter famous, right? No? Okay. Wow, this is a tough room. Yes, I know it's early. I'm over-caffeinated, so yeah, good luck with that. So when I've been talking about DI for a long time, and when I first put this talk together, I was like, OK, I need a definition of dependency injection, right? Something that we can wrap our heads around and figure out, OK, what is this thing? Why do we want to use it? How is it awesome? And so I decided, let's go to Wikipedia, right? Because Wikipedia is nerds arguing with nerds. So I figured this will be a really good place to start. And this is the definition that was on Wikipedia back in 2012. And it says, dependency injection is a software design pattern that allows a choice of component to be made at runtime rather than compile time. And I looked at this, and I'm like, the nerds have let me down. Because this talks about one specific benefit of dependency injection, which is runtime binding or late binding. I would even argue that's not even the most important benefit that we get out of it. And so I'm like, oh, OK, that's no good. Guess I have to look somewhere else. Well, since I've been doing this talk for a while, I decided, yeah, well, let's give the nerds another chance. So in 2013, we got this definition. Dependency injection is a software design pattern that allows the removal of hard-coded dependencies and makes it possible to change them, whether at runtime or compile time. OK, that makes me feel a little bit better, because now it tells me, OK, we're removing hard-coded dependencies. It doesn't really tell me why, though. Now, unfortunately, in 2014, things kind of went off the rails. Dependency injection is a software design pattern that implements inversion of control and allows a program to follow the dependency inversion principle. The coin was turned by Martin Fowler. Great. Now you've just taken away all meaning and given me two other things I don't understand. Inversion of control and the dependency inversion principle. Thank you, Wikipedia. Well, things didn't get better. 2016 is kind of where I gave up. So I have no idea what it says today. I gave you nerds 5 years to argue with each other. So we're going to just forget Wikipedia. And I'm going to use this definition. And this one comes from Mark Seaman. Dependency injection is a set of software design principles and patterns that enable us to develop loosely coupled code. What I really love about this definition is it tells me what the goal is. My goal is loosely coupled code. Yay, I like that. Great. Now you might say, why should we listen to Mark Seaman over Wikipedia? Why is he so much smarter? Well, when I was learning about DI, I was looking for books because I'm a book person, that's how I learn. And since I'm in the .NET world, I was looking for .NET books. And back in 2012, there was exactly one dependency injection book in .NET, which is this one by Mark Seaman. And it is an excellent book. Now, for those of you who have read this book and love it, or maybe not, there's a second edition that is on its way, which is awesome. I don't know if it's done yet. It was in early access last time I looked. But what I really like about this is Mark Seaman has done his research. And so like on every third page, there's a footnote to a white paper or a PhD thesis or some article. So he's actually done his research and made it really, a really thorough investigation. So if you want to dive deeper, this is where I would go for that. But let's talk about, what do we care? Why do we care about dependency injection? And there's actually a number of benefits. The first one that I like is extensibility. If we have loose coupled code, then it's really easy to take these pieces that are just kind of building blocks and add another one or swap one out. I disconnect this one and put this other one in. So I can change functionality and extend functionality really, really easily with with this loose coupling. Another one is late binding. Now, again, this is from the first Wikipedia definition. And what that means is that I don't have to decide what I'm using at compile time. I can make decisions at runtime based either on configuration or maybe just what DLLs are available to me. And that's pretty cool. And there's times where I've needed that. Now, there's some drawbacks to that, too. It makes it harder to debug. But if you need that runtime binding, it's really cool stuff. Another one is parallel development. I've primarily been a corporate developer in my career. And so I work in teams. And the worst thing that happens to you when you work in a team environment is when you go to check in your code to source control, and you get that great pop-up that says, how would you like to merge these files? Right? And the correct answer is, I do not want to merge these files, right? Just take my stuff. So when we have kind of these loosely coupled pieces, basically what we have is the people who are working on the libraries are kind of in this area. The people who are working in the UI are in this area. And the data access is kind of over here. And they don't really cross over at a file level, once we kind of figure out the interfaces and APIs that they're communicating with. So having those merge conflicts is much, much less frequent, which I love. Another big one is maintainability. If I do have a spot for my business code and for my UI code and for my data access code, when something goes wrong, I know what section of the code to go to. I don't have SQL statements just kind of sprinkled throughout my entire application. If you've ever experienced that, you know the fun that is. So it makes it easier to maintain. And then the last thing that I have on my list is testability. I did not used to be a unit tester. I thought I was doing OK, and it turns out I was wrong. Unit testing made me a faster developer. And that's hard for me to believe even, but I've done an entire talk called Unit Testing Makes Me Faster. And if you go out to my website and look for the links for this talk, you'll find a link to that as well. So unit testing is huge in my world. And when we have loosely coupled pieces, our code is easier to test. And there's a side effect that we get when we're doing this, and that is adherence to the solid design principles. If you're not familiar with solid, it's a set of 5 object-oriented principles. And by doing dependency injection, we actually hit 4 of these 5 principles. Now, the ones with the asterisks are the things I'm going to talk about today. So I'll show specifically extensibility and testability. And I promise I will not talk about the solid principles because A, I don't have time, and B, I always forget. But if you go to my online resources, you can see that it does actually hit 4 of those 5 principles. So these are the benefits that we get from loose coupling. Not dependency injection specifically, but from loose coupling. Now again, dependency injection helps us get there. And there's a lot of concepts. I'm just going to mention these here because we're going to be looking at them as we go. First is there's a lot of different design patterns. There's constructor injection, property injection, et cetera, et cetera. So there's more than one way to do dependency injection. So don't just think there's one way to approach this. And each of these have their pros and cons. And again, if you want to dive in deeper, the Mark Seaman book kind of goes into kind of when you want to use all of these. I primarily use constructor injection and property injection, so I'm going to be showing constructor injection today. Another concept is object composition. You might hear the term composition root. And this is the spot where we snap our loosely coupled pieces together. And so we'll be seeing that as well. And then, of course, there's DI containers. These are some of the most popular ones in the .NET world. They're all free, and they all are pretty full-featured. So what's nice about the .NET world in particular is that these containers all have pretty much the same functionality. So if you're trying to do things, you don't have to say, oh, well, AutoFact can do this, but Unity can't. Or Ninject does this, but Structure Map doesn't. They all have the same capabilities. They take different approaches and syntax and things like that. But what it means is we can make our decisions on which container to use on other things. So for example, if you're one of those places that says, we love Microsoft, Microsoft is what we do, then you might want to pick Unity because it was originally created by the Microsoft Patterns and Practices team. It's been released into the wild now. If you're using some of the ORM tools or other things from the Castle open source project, you might want to look at Castle Windsor for your DI. If you're in a mixed environment where you have Java code and .NET code, you might have heard of Spring in the Java world. Well, there's Spring.NET, which is a port of that to .NET. And that's a lot more than just dependency injection, but it has DI in there. So if you have a mixed environment, you might want to use Spring and Spring.NET so that your code looks the same across your environments. So we can make decisions that way. OK, so here's where I'm going to get to code. And I'm going to show you an example program that is more complicated than it needs to be and simpler than it needs to be. Is that confusing? OK, so it's simpler than it needs to be because I'm going to be showing a one-screen application. Normally, I wouldn't use DI in a one-screen application. But if I were to show you kind of the full applications I normally use dependency injection, we could get lost in business rules and communication between modules and all that other fun stuff that we have to put up with. So I'm going to show a one-screen application so we can keep things simple. Now, it's more complicated than it needs to be because I've taken this one-screen application and split it up into 4 discrete layers. And in this case, I'm using something known as the Mvvm design pattern. Right? And that you're supposed to use that because it makes you sound really smart. Basically, what it means is up at the top, I have the view. And these are my UI elements. So in this case, I'm using, this will be our buttons and our list boxes and things like that. The view model, the level right below that, is our presentation layer. And this is the logic that drives our UI. And then below that, I have a repository. And this is a way that we can interact with our data store so that our main application doesn't have to understand, how do we work with SQL, how do we make HTTP calls, how do we do whatever. So it's a layer that allows us to kind of encapsulate that special code so that the rest of our application can just deal with standard objects that it knows how to deal. And in this case, I have a service layer down at the bottom, and this is going to be a service that's providing us with data. So that's all it is. OK, and that was a mouthful. So I'm going to show code now. Is that OK? Anyone want to see code? Woohoo! OK. Before I show you code, I'm going to wow you with my UI development abilities. Are you ready? Ta-da! 2 buttons and a list box. OK, it gets better. Watch. Do-do-do-do-do-do. Data. Yay. Oh, there's one person in the back that's really excited about that. And for those of you who want to just shut off right now, you're done. A little challenge, you can figure out what my data set is. And if you can do that without using an internet-connected device, come talk to me today, because you're the kind of geek I would like to hang out with. Yeah, OK, I'll leave it up there for a second so you can see it. It'll be back, don't worry. OK, so I have actually taken this application, like I said, and split it up into discrete layers. And I put them in the same order here in the solution. So if you download the code yourself, you'll be able to see that pretty easily. So we have at the top our view in the people viewer. And I'm using WPF because XAML is awesome. And then in our presentation layer, again, that's where our view model will be. Our repository is, again, that intermediate code that knows how to talk to a service. And I have a service down at the bottom. And there's also a shared project. I'm going to start down at the bottom level of our application and look at the service. OK, this is where I give you a warning. This part of the presentation is quite tedious. And I wish I could fix it to make it not tedious, but we have to get through the tedious to make the awesome really awesome. So trust me, just hang in there. We'll get there. OK, so the bottom layer, we have the service. And in this case, I'm using a SOAP service. And if you want to talk about SOAP and REST and what each is good at, I'll have that discussion for you at the break. In this case, I have a service that is called person service. And it has 6 methods: get people, get person, add person, update person, delete person, update people. So this is just going to provide us with data. And if we look at what a person object is, we can just peek at that. It's a pretty simple class. It has 6 properties and an override of the toString method. So that's just the shape of our data that we show in our UI. And it gets even better because in this getPeople method, it's hard-coded. So I'm not even hitting a database or anything. It's just supplying us with hard-coded data there. So this is the bottom layer of our application, our service layer that's providing our data. If I go up from there, I hit our repository. And again, our repository is here so that the rest of my application doesn't have to know how to make HTTP calls in order to communicate with that service layer. And let me just collapse the definitions here so we can take a look at this. So in this case, I have something called a service repository. And in the constructor, I knew up an instance of the person service client, and this is a proxy class that knows how to talk to that SOAP service. And then this has a getPeople method as well that returns an IEnumerable of person. And this basically acts like a pass-through. So this is just calling the service's getPeople method and returning whatever comes back from that. So in this case, it seems like, why is this layer here? But inside this service proxy is wrapped up all the code that knows how to talk HTTP, make requests across the wire, bring them back, put them into C# objects that my application can use, so that my application can just make these really simple calls and say, hey, get people, and it gives me back an enumerable of person objects. So we've seen our service layer down at the bottom. This is our repository layer. The next layer up from this is our presentation layer, which is in our view model. And here I have a class called main window view model. And let's scroll this guy down a little bit. Now you can see up at the top I have a protected field, which is the service repository. OK, so that's the class we just looked at. And then in the constructor, I'm newing up an instance of that service repository. And then here I really have kind of 3 pieces of functionality. I have a refresh people method, and that can be hooked up to our button that we can click on to refresh the people. And then there's a clear people method way down at the bottom of this file. And we click on that, it will clear out the people. And then I have a people property. So you can see that IEnumerable of person up there. And what happens is this is data bound to the list box in the UI. So when we call the refresh people method, it will call into the repository and put stuff into this people property. And through data binding, that shows up in our list box. Are you still with me? Yeah, I know, a little tedious, like I said, but trust me, it gets there. We'll get there. OK, so we've seen our service layer down at the bottom and our repository on top, and this was our presentation layer. The last layer we have to look at is our view, which is at the top. And again, this is the UI elements of our application. Now, like I mentioned, this is a WPF application using XAML because I really like XAML. And I'm just going to scroll down to the list box and point to this line right in the middle that says item source. And this has a binding to a people property. So what this is saying is, hey, I would like to be data bound to the people property, and that's what I'm going to show in this list box. So this is just how we hook up the data binding. Now, we might say the people property on what object, and we'll see that in just a bit. In fact, we'll see that right now, because I'll flip to the code behind of this form. And we can see at the very top, I have a field for the, or actually that's a property for the main window view model. So again, our view model provides us with our presentation logic. In the constructor, I'm newing up an instance of the view model to populate that property. And then I have 2 button click event handlers, one for the refresh button, one for the clear button. So we can see the refresh button underscore click calls the view model.refreshPeople method, the one we looked at in that other class. Okay, so how does it all get hooked together? Well, it's actually the third line in the constructor, this data context equals view model. The data context in a XAML application tells us this is what you are bound to. So when I have that binding that says, hey, listbox, you're being bound to the people property, and it says, well, people property on what? It looks at the data context, and in this case, it'll be the data context of the window, and says, oh, the people property on this main window view model. Whew, that's a lot of layers. Like I said, more complicated than it needs to be. So let's run this application and think about what's happening. So when I come up here and click on the refresh people button in my view, it calls the refresh people method on my view model. The view model calls the get people method on the repository. The repository calls the get people method on the service. The service returns a collection of person objects to the repository. The repository returns a collection of person objects to the view model. The view model assigns that to the people property through data mining. That ends up in our list box in the UI. Whew. That all happens when I click this button. Are you guys impressed with my programming skills yet? Yeah, OK, great. So when I look at this, I'm feeling pretty good about what I have so far. But it turns out that when I look at this, it's not quite as good as I think it is initially. Because when I first see this, I'm like, separation of concerns. We're told that different functionalities should be in different areas. Well, I have that, right? My data access code is really in my repository. My UI elements are in the view. You know, this stuff has good separation. I feel pretty good about this. But this application actually has kind of an insidious secret. Because even though we have good separation of concerns, sort of, we have tight coupling. You might say, great, tight coupling, something else to learn about. What does Jeremy mean by tight coupling? Let's go back to our code. Oh, we'll shut down our application. And take a look at our view. Again, this is the top layer of our application. Now, if you notice in the constructor of the view, I'm newing up an instance of the main window view model. Now, there's a great article by Steve Smith, and thank you for sitting in my room rather than Steve's room. So, yeah, so Steve has this great article called New is Glue. And again, if you follow the links to my website for this presentation, you'll see a link to his article. So usually I have to say it's hard to find Steve Smith online, but you guys can find him in person today. So go hunt him down. So new is glue. And basically what that means is when I look at this, what does this mean? When I new up an instance of that main window view model, there's a couple things that happens as a side effect. First, I have to have a compile time reference to the main window view model. If I don't have a compile time reference, this won't compile, right? The second thing in this case is that when we new something up, we now kind of become responsible for the lifetime of this object, right? And is that something that I want my view to do? Probably not. There's also, the other thing is I'm actually selecting which object I want to use, which for the view is kind of OK in this case. So what I'm really seeing is that my view is tightly coupled to my view model. I have to have this compile time reference, taking responsibility for things for lifetime and stuff like that. But this application gets worse, because if I look at the constructor for the main window view model, what I find is that this is newing up an instance of the service repository. And even better, I'm kind of selecting what data store to use. I'm saying, hey, you know what? I want to hit the service. So I'm going to new up this specific object that goes against a service. Same thing, compile time reference, making decisions, responsible for the lifetime of the object. So it turns out that my view model is tightly coupled to my repository. And it actually gets a little bit worse, because if I click into my repository, I find out it's newing up an instance of a connection to my production service. So same thing. Now, that coupling doesn't really bother me too much, because my repository and service kind of have to know a lot about each other in this case. But what really bothers me is the implication of all of this tight coupling. Because my view is tightly coupled to my view model is tightly coupled to my repository, and my repository is tightly coupled to my service. That means that my view is tightly coupled to my service. that starts to worry me a little bit more. Does that scare anybody in the room? No? Oh, OK, there's like 3 people that scares. And quite honestly, in this little one-screen application, should I be scared? I don't know. But it's kind of a cool application, right? Yeah? So I take it to my boss, and I say, hey, boss, look at this cool application that I built. It gets people out of a service and shows them on the screen. Isn't that awesome? And my boss says, yes, Jeremy, that is awesome. This is exactly what we need for our clients. But, my experience, bosses always have a big but. But not all of our clients use SOAP services. Some of them use SQL Server. Some of them use Oracle for an Oracle database. Some of them use REST services. Some of them use CSV text files. OK, I think I can do that. So let me look at the view model, because this is kind of where that decision is made. And I'm thinking, OK, right now I'm doing up a service repository object, but I think I can put a switch statement in here. And so I can say, based on configuration, you can do Oracle or SQL or CSV or whatever. OK, it doesn't feel right, but that's doable. And bosses always have a big and. Because kind of the most expensive part of this application is traveling across the network, we want a client-side cache that's configurable for each repository. OK, well, I guess I can make a service repository and a caching service repository, and a SQL repository and a caching SQL repository, and a CSV repository and a caching CSV repository. That switch statement doesn't feel quite as good, but it's doable. OK, yeah, I think I can do this. And we should have unit testing, which I thoroughly agree with. So let me think about what would happen if I wanted to unit test this view model class. Well, when I'm in my unit test, I'm going to instantiate this main window view model. And by default, I get a connection to our production service. And what that means is that even though I'm not testing my service in this unit test, I just want to test my view model, if that service isn't running, isn't there, my unit test is going to fail. And that's something I'm not even testing right now. I do want integration tests that test it all the way through. I want to have tests for my service. But when I'm testing my view model, I don't want to have a dependency on this production service to be running. That doesn't make any sense. OK, well, here's another option, because .NET has this cool thing called reflection, right? Reflection. And so I can actually go in and pick out this protected field and replace it with something else, and end up with about 30 lines of reflection code. Well, here's the problem with that. If you have a unit test with 30 lines of reflection code in it, nobody's ever going to read it. Nobody's ever going to write new tests. In fact, the first time that test fails, someone's going to go in and look at it and say, I don't understand this. They're going to comment the entire thing out. So really what I want is I want code that's easy to read and write, and unit tests that are easy to read and write. And yes, we can have both. So my boss wants all these things. And yeah, I can cobble something together, but there's actually a much better thing we can do. Does anyone have any idea what that might be? Dependency injection. Yes, good. There's one person who's still awake. So that's the tedious part. So thank you for hanging on. Now, what I'm going to do is I'm actually going to flip over to another project, another solution. And this solution is actually in the same state as the one we just left. But I didn't want to scare you by just opening this up immediately, because this also has some additional projects. So if I zoom in on this, you can see I've got the people viewer at the top in that application view section, same WPF application we looked at before. But I've got a couple others to show Ninject, which we'll look at later on, and Unity late binding, which you can go online and find that information. Presentation layer, exactly the same thing. The service repository, exactly the same, but I've got a couple other repositories here. The service, again, exactly the same, and our common area. And I've got some unit tests stubbed out. Well, when I think about what I want to do is I really kind of want to break the loose coupling in my view model. So let's see what I need to do. First of all, I'm going to loosen the coupling a little bit by changing the type that I have for this protected field. Right now it's a concrete type, a service repository. But it would be nice if I could just refer to an abstraction instead. And for that, I'm going to use an interface. Interfaces were another thing that took me a really long time to learn. And so I have all kinds of materials online about learning interfaces, because those are also really cool. If you're not familiar with interfaces in the .NET world, it's basically a contract. So here's an interface called iPerson Repository. And it's an interface that just declares members. Okay, you'll notice there's no implementation for the methods that I have listed here. It just says, hey, there's 6 methods: get people, get person, add person, update person, delete person, update people. So I have these 6 methods, and this basically becomes a promise. So any class that says, I implement this interface, is promising I will have these 6 methods. And since I extracted these from the service repository, I've actually already added the interface notation here. So my service repository, I'm saying, hey, my service repository implements iPerson repository, so it will have those 6 methods. And again, we do have those, which we saw earlier. And I know you guys don't trust me yet, so I'll show you them again. Do you guys trust me? Oh, sweet. OK, well, there they are. So get people, get person, add person, update person, delete person, update people. And so what that means is in my view model, I can come back here and change this type to an iPerson repository. And this can be the abstraction rather than a concrete type. And I can build and run this, and it will run exactly the same as we had before. But what I really want to get rid of is I want to get rid of this new. Because my view model is responsible for presentation logic. And selecting the data store that I'm going to use is not the responsibility of my presentation logic. So it really shouldn't be the responsibility of the view model. So I'm going to take the approach that I normally do, which means I'm going to make this somebody else's problem. Does that sound good? I'm going to make this somebody else's problem. So rather than doing this up myself, what I'm going to say is I'm going to add a parameter to my constructor. I'm going to say whoever wants to instantiate a main window view model has to provide me with an already instantiated class that implements iPerson repository. Now it's somebody else's problem. I haven't eliminated the dependency. Okay, I still need a repository. In my refresh people method, I need the repository so I can call get people on it. But rather than taking care of that dependency myself, I'm having someone else inject that dependency, hey, dependency injection, through the constructor. That's why this is known as constructor injection. Now, I know it just looks like we added a parameter to our constructor, but what we really did was constructor injection. And you should make sure you say that, because it makes you sound a lot smarter when you're talking to your boss, right? So we just did constructor injection. That's not very hard, is it? That's easy. Great, let's go ahead and run our application and see how awesome it is. So let's build, and oh, man. OK, maybe it's not that easy. OK, so let's go to our build failure and see what happens. Oh, OK, so now I'm in my view, where I'm trying to new up that main window view model. And it's saying, oh, you know what? You need to repository. And I could say, oh, OK, so var repository equals new service repository. But if selecting the data store is not the responsibility of my presentation layer, it's really not the responsibility of my view layer, right? Because my view is like, here's the UI elements. OK, so what should we do instead? I'm going to make it someone else's problem. So I'm going to say, whoever gives me this main window has to give me a main window view model. That sounds easy enough, right? Make it somebody else's problem. I love this job, right? How hard can that be? Now, I am not using an interface here. I'm still using the concrete type main window view model. And that's because just in the experience that I've had with Mvvm, I've done a lot of view models in my day. My views and view models are generally one-to-one relationships. So I don't like to add that layer of abstraction unless I actually need it for something. So in this case, I'm going to use the concrete type. But if I had to put multiple view models on this, I'd probably add an interface later. OK, so we've just added a parameter to our main window. Let's go ahead and build. Ooh, build succeeded. I like that. Cool. Let's run our application and see how awesome this is. Seems like I have a runtime error. And do you notice the code that this is pointing at? Yeah, it's not pointing at code. Yeah, this is fun. So basically what this means, if you're in the XAML world like I am, is the XAML actually gets compiled into an object that C# can actually understand, or the .NET runtime, I should say. And so what's happening is it's using that compiled code and saying, oh, there's something wrong in your XAML. Like, OK, great. I won't tell you how long it took me to figure this out the first time this happened to me. But trust me, if you get a form like this and you're doing any kind of XAML application, there's probably a problem in your XAML. And it turns out there is. Let me go ahead and stop debugging. And I'm going to flip over inside my view application. There is an app.xaml file. And this represents my application. And just like our forms have markup in code, the application itself in a XAML application has markup in code. And specifically, I want to look at the last line that I have here in this first tag. So I have a startup URI, which says mainwindow.xaml. And what happens is when this application is starting up and it sees this startup URI, it says, hey, you know what? I'm going to create a main window class, and I'm going to use its no-parameter constructor in order to do that. Well, we got rid of the no-parameter constructor, right? We don't have that anymore. So this is blowing up. This is why we're getting that runtime error. So the first thing I do when I find a piece of code that's causing me problems is I delete it. Right? That's a good approach, right? OK, so let's go ahead and build. Build succeeded. Great. Let's go ahead and run our application. And no runtime errors. OK, there's no main window either, but there's no runtime errors. Right? Baby steps. No runtime errors. OK, you probably want me to fix this, don't you? OK, well, just like we have code behind on our forms, inside our markup, for our application, there's also a code behind. So I'm just going to flip to the code. And you can see I've already got an override for a method in here. I'm just going to uncomment this out with the keyboard shortcut Control-K, Control-U. I love keyboard shortcuts in Visual Studio. They are awesome. Yeah, aren't they? Because I'm a lazy developer. Any lazy developers in the room? Yeah, real lazy developers don't raise their hands. So I got a really good idea now. So this is the code that it's trying to run with the startup URI. So we can see I've got an application.current.main window. And this describes the main window for my application class. So it's trying to new up this main window object and assign it to this main window property using a no-parameter constructor, which, as we can see, we got squigglies. It doesn't work. And then after that, it shows the main window. OK, well, let's fix this. What does this need? OK, this wants a view model. OK, so I'll say var view model equals new main window view model, just like that, and we'll pass it through. OK, great. My view model wants something. OK, it wants an iPerson repository. OK, var repository equals new service repository, and we'll pass that through right there. You know what I've just done? I've just created loosely coupled pieces and snapped them together. In fact, I'm going to split this out into a separate method, control.extract method, and I'm going to call this compose objects, because that's what I am doing. I'm taking my loosely coupled pieces and I'm snapping them together. And so when I run this application, I see I get successful build, I get a successful run, and when I click the button, we have exactly the same thing we had 20 minutes ago. Yay. Great. Exactly the same thing we had 20 minutes ago. But it turns out we're in a much better position than we were in 20 minutes ago, because this loose coupling helps me make my boss happy. OK, does anyone remember the first thing my boss wanted? It was a really long time ago, wasn't it? Various data sources. Woohoo, I like that. Yes, so various data sources. How do we do that? Well, in my repositories folder that I have in this project, I have a couple other repositories in here. And I'm going to open up a CSV repository. This is something that knows how to talk to comma-separated values in a text file. And we'll just collapse to definitions to take a look at this. So this CSV repository implements that interface iPerson repository, which means it has those 6 methods: get people, get person, add person, update person, delete person, update people. But it behaves quite a bit differently. If I open up the get people method, it's using a stream reader to crack open a text file and turn it into these person objects that I want. So it's processing things quite a bit differently than the service repository I have. But because it implements this iPerson repository interface, it will plug into my application, and my application doesn't care. And that's what's awesome about this. Because I can go back to where I'm composing my objects and just snap my pieces together in a different order. So instead of using the service repository, I can use the CSV repository. And now when I run my application and click the button, I'm getting data from a text file instead of from a service. And the reason I know that is because the text file has an extra record, Jeremy Awesome. Right? So I have visual proof on screen that I'm hitting a different data source. That's pretty cool. Wow. That was easy. I just made my boss happy. And if I need an Oracle repository, SQL repository, I just build new DLLs, implement the interface, and they plug right in. Now, in the scenario I described, we'd probably want to use late binding, where we're making runtime decisions rather than compile time decisions. But you kind of get the general idea, right? It's really easy to swap out these pieces for something else. Great. What's the second thing my boss wanted? Caching, client-side caching. OK. For this, I'm going to use something that's known as the Decorator pattern. And basically what this means is I have my view model, and it's expecting an iPerson repository. And right now, we're plugging in a service repository to that. But using the Decorator pattern, what we can do is we can take our real repository and wrap it in another class. And in this class, we can add our own functionality, which in this case will be caching. But then to the outside world, we expose the same interface. So this will be an iPerson repository. So to the outside world, it looks just like any other repository. Let me just show you real quick what that looks like in code. I have another class in here, which is a caching repository. And let's go ahead and collapse to definitions. And in this case, I have some fields at the top that deal with the cache. So this, in this case, is setting up a 30-second client-side cache. And then you can see I have a field here for a wrapped repository. So I'm taking a real repository that I'm actually getting my data from, wrapping it, adding my custom logic for caching. And you can see I'm using Constructor Injection here as well. So in the caching repository constructor, I'm saying, hey, give me a real repository that I can wrap and get data from. And to use this, all I have to do is snap my pieces together in a different order. So if I go back to where I'm composing my objects, instead of using the CSV repository, I'm going to use the caching repository. And again, this wants an iPerson repository to wrap. So I'm going to call this wrapped repo, and we'll new up a service repository. I'm going to use the service repository because it's easier to demo, but this would work with any of the repositories that we use. So what I've just done is just taken my loosely coupled pieces and snapped them together in a different order. And now when I run the application, I have a 30-second client-side cache. Do you guys believe me? Of course you don't, because this is not very impressive. So I just got data from a service. I'm going to come up here to my IIS Express, which is running my service, and I'm going to exit out of that. That means my service is no longer running. But I can click on Clear Data and refresh people and get that client-side cache for 30 seconds. And I can just keep clicking back and forth until this expires. And 30 seconds is a really long time when you're doing a demo live on stage. But whenever I set it to less, then it's always not long enough. OK, so cache expired. So it's trying to go out to the real repository, in this case the service, and get fresh data. Well, the service isn't there. And so it's actually returning an exception, or throwing an exception, I should say. And in this case, I programmed the caching repository that if it can't connect to the real one, just give me a no data available record. So we just saw client-side caching working. Wow, that's impressive. Just snap pieces together in a different order, have client-side caching? Wow. OK, what was the third thing my boss wanted? Unit testing. And I actually have some tests set up, and we can see how much easier these are. So again, if we were looking at testing with the hard dependency, we're looking at potentially a lot of reflection code. But let me just flip back to my view model real quick so we can take a look at what we're going to be testing. So my view model is actually pretty simple. There's not a whole lot of functionality here. But what I want to say is, hey, if I call this refresh people method, at the end of this, I expect the people property will be populated, because that's the only thing this is doing. And so I want to write a test that does that. And so here's my test for that. And we can see that the first line of this is I'm getting a test repository, and I'll show you where I get that. Then I just pass that in to the constructor of the main window view model. That instantiates my view model. Then I call the refresh people method. And then I verify that my people property has what I expect. OK, so in this case, that it's not null, and that it has 2 items in it, because that's my test data. So now instead of having 30 lines of reflection code, I have a 5-line test. I'm going to write those all day long. And they're really easy to understand. And the setup for this, I'm doing some mocking. That's just in this method here. And I'm setting up a list of 2 objects, and then using mockQ to create a mock object. Totally don't have time to talk about that. But that basically creates a fake object in memory that I can use in my test. So I'm never hitting my production service, and I don't have to worry about all these other dependencies that I have no control over. That's cool. I really like this. Does anybody else think this is really cool? Yes, thank you. I always feel like I'm really overexcited about this. Oh, wow, I'm doing really good on time. So remember how I told you I didn't have time to talk about property injection? Apparently I lied, because I'm going to show you property injection real quick. So constructor injection is great, because when someone news up an object, so let's just scroll back down to our unit test here. So when someone news up this main window view model, I'm forcing them to provide me with an implementation of something. So you have to make a decision. But what if I have a situation where, 99% of the time, I want to use this default implementation, but I kind of want to be able to swap it out for unit testing? Well, there's another pattern we can use called property injection, and there's a couple ways of implementing this, but I'll show you the way that I'm using here on the service. So basically what I want to say, or I'm sorry, on the service repository. Service repository, there we go. So basically what I want to say is I have this service repository, and I want to test it, but I don't want to connect to a production service. I just want to kind of mock that up. Just kind of like I mocked it up for the view model. So what I've done is I've added a property, and rather than newing up this person service client, this connection to the production service, in a constructor, I've done it in a getter of a property. So what happens is I have this service proxy property, and in this get, you can see if the backing field is null, then I'm going to new up a new connection to the production service, the person service client. And then I'm going to return that. But if the backing field is already populated, I'm just going to return whatever's in that backing field. And so what that means is that when I call this getPeople method here, serviceProxy.getPeople, it's going to say, oh, service proxy, is the backing field null? Oh, yes, it is. Let me go ahead and new up a connection to the production service, and then give that to you. And then it'll call the getPeople method on the production service. That's what I want to do at runtime. That's what I always want to do at runtime. But for testing, I want to swap that out. And what I've just done is given me a little hook for that. So if we look at the unit tests for the service repository, this is going to look kind of similar to what we saw when we were looking at our view model. So you can see I new up a service repository class, and there's no constructor parameter, so I can just new that up. But then, before I make any function calls on this, I set the service proxy property to my test service rather than my real service. And then I can call the get people and do the validation on that. And let me show you the implications of this. So here's my test explorer. Let me just close this guy. And we will run all. And we should see our tests all pass. Yay, I like to see that. Now, what happens if I don't override this service proxy property in my tests? Well, if I run, I'm going to get a test failure. And if I look at the message for the test, you'll just have to trust me on this. Basically, what it says is, hey, you know what? You don't have any configuration information on how to connect to a service. So I can't find this production service that you say I'm supposed to find. Well, I don't want to use the production service. So I can use my fake service instead. And that's what's really cool about this. Now, this is something that took me a little while to wrap my head around, so you're probably going to want this to settle a little bit. But constructor injection and property injection are the two primary patterns that I use. Constructor injection works for me most of the time. And in that one, I force someone to make a decision. You have to pass me something. With property injection, I say, hey, you know what? You don't have to pick anything. If you don't pick anything, I'm going to use my default, which is connecting to production in this case. But you have the option to do something else for testing if you'd like to do that. So those are kind of the two scenarios that have worked really well for me. OK, so I've done all of this with no DI containers at all. Right? Are you impressed with that? Sometimes we don't need DI containers, but DI containers are pretty awesome. So what I want to show you is how we would do the same thing with Ninject. And I have another project in here called peopleviewer.ninject. I'm just going to set that as the startup project. And we're going to look at the app.xaml. So this is our startup where we were manually composing our objects before, newing things up and stapling them together. Now, instead of doing that, I'm going to use Ninject, which is one of the popular containers in the .NET world. And I've already brought in the NuGet packages and added service references and things like that. So I'm just going to add the container and configure it and show you how we use it. So in this case, the interface that Ninject uses is called iKernel. So we're going to go ahead and create a class level field in this case, which represents the container. And then you see I actually have two separate methods down here, a configure container and a compose objects. In the configure container, first thing I'll do is new this up. Container equals new standard kernel. And then what I need to do is I need to tell Ninject how to match up concrete types with abstractions. Now, in my case, my abstraction is my iPerson repository. OK, so I have an interface, iPerson repository, and I need to tell Ninject, if someone asks for an iPerson repository, here's the concrete type you should use. Now, I really like the syntax for Ninject because it's very straightforward. So I can say container.bind iPerson repository .to service repository. So I can just bind the abstraction to a concrete type. OK, cool. OK, so that's configuring my container. How do I get something out of this? Because I need to get that main window class out. Well, down here in compose objects, I'm going to say application.current.mainWindow equals, and instead of saying new main window blah, 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 I'm going to say container.get main window. So I'm just going to ask Ninject, hey, Ninject, get me a main window class, or an instance of the main window class. This is all the code that I need. And that's the problem, because it is a bit magical. Now, I know you guys still don't trust me. We've been here for almost an hour. But I click on the button, and it works. OK, maybe Jeremy's using some trickery here. Well, let's change this binding from the service repository to the CSV repository, run the application again. Well, there's the extra Jeremy Awesome record. That means this is working. But I have a problem. Where is my view model? Where's my view model? When we did this up manually, we had to have a view model in there. But when I'm using Ninject, I don't have to. And this is the magical part of containers, which is really cool. But if this is how we're introduced to DI, we're like, I have no idea what's going on. Well, let me tell you what ninject is doing in this case. When I say, hey, ninject, get me a main window, it says, OK, do I know what that is? Yes, I have a compile time reference to a main window class. Let me look at all of its constructors and pick the most complex one that I understand. I won't go into the details of that. In this case, we have one constructor that needs a main window view model parameter. Ninject says, hey, do I know what a main window view model is? Yes, actually, I have an assembly reference, and it has a main window view model class in it. Let me look at its constructors. And in there, it finds one constructor that wants an iPerson repository. And it says, OK, do I know what an iPerson repository is? And it says, yes, I actually have a mapping here that says if someone asks for an iPerson repository, I should give them a CSV repository. Do I know what that is? Yes, I have a concrete reference to that. Here's a class with a no parameter constructor. It news everything up, puts them together, and gives me back the thing that I asked for. So that's what's cool about it. It's magically handling all of that. But again, if we don't understand, like, there's a chain hidden behind this, basically the way that I started using DI containers was copying and pasting, changing a few things, and crossing my fingers. Seriously. Because I didn't understand the stuff that was behind it. But now that I understand kind of how things are going on, especially if I have this chain of constructor injection like we have in this application, now it becomes that much cooler. Now you might say, OK, well, why do I want to use a container? Well, there's all kinds of cool stuff. Because, for example, in inject, we have .in. And you can see I have in scope, in Singleton Scope, in thread scope, in transient scope. So the container will actually manage the lifetime of these dependencies. If I say in Singleton Scope, then what happens is it will create one and only one instance of the CSV repository. First time I ask for it, it'll create one, give it to me. Second time I ask for one, it gives me the same instance. If I were to say transient scope, it would give me a new object each time I asked for it. So I get a fresh implementation every single time I use it. If I say in thread scope, I get a new implementation for each thread that I'm on. Wow, you do not want to code that up yourself. Trust me on that. And so there are a lot of features in DI containers. We have looked at less than 1% of what ninject can do today. So just kind of give you some advice to go out and look at them, because they are very, very cool. So actually, let's get rid of this. So I like my code to compile. I don't like red squigglies. Red squigglies make me really nervous. OK, let's just make sure this still works. OK, cool. Boop. So again, let's use the DI containers and get the things that we need. But we can see that by adding the loose coupling, adding the dependency injection, that we're in really good shape. So we broke the tight coupling between our view model and our repository. Yay, right? When we added the interface and added the constructor injection. What that also meant is we broke the coupling between our view and our service, which is what I was really concerned about. We also loosened the coupling a little bit between the repository and the service by adding the property injection. But again, in this situation, it was really that tight coupling between the view model and repository that was stopping me from doing what my boss really wanted me to do. So let's see, how did we do on concepts? Well, we did see constructor injection. Constructor injection, again, it's just a constructor parameter. It's not that complicated. But again, if constructor injection doesn't do what you need it to do, we do have other patterns that we can choose from. And so we can look at each of these and see the pros and cons of each of them. Again, constructor injection is great because it's very obvious what you need. There's nothing hidden. It's right there in the parameters. If you don't supply the parameter, it doesn't work. So I like constructor injection because it's very obvious. Property injection, again, that one's hidden. I might not know that it exists because it'll just do something by default if I don't choose to do something otherwise. So, and then method injection, ambient context service locator, they all kind of have their pros and cons, so we can look at them in more detail. Now, I did show object composition, where we snapped our loosely coupled pieces together. In my application, I was doing it right at application startup. But we might be doing it at modules. We might be doing when someone loads up a particular web page, we go out and get the dependencies that we need for that particular page. So how we do this, again, it will depend on our needs. There's a lot of options of doing this. And I showed you Ninject. Again, I like Ninject because it's a very simple, approachable syntax. I've also used Unity in a production environment which is, it's very powerful and has a lot of options, but it also has Microsoft-style naming. So it's a little difficult to understand. But the documentation is good. And then as far as the benefits, we saw extensibility. We saw how I could swap out the different repositories very easily. We saw how I could add caching to my application very easily. And then we also saw how readable our unit test would be. And if you go online, I do have samples that show late binding. And again, what that will show is, hey, let's make a decision at runtime so that I can just give each client the one DLL that they need for their repository with some configuration, and they can just load up whatever repository they need. And as promised, I did not talk about the solid design principles at all. So thank you very much for hanging out with me. I am also a Pluralsight author, as I mentioned, and I do have a course, Dependency Injection on-ramp, which is 2.5 hours long, so it has more information in there than I showed you today, but there is that information available online. And again, if you head out to my website, you'll find the slides, code samples, links to all kinds of articles, as well as links to the other presentations that I mentioned that were related. And if you have any questions, I am going to be checking the yellow Slack. So if there's stuff out there, I will be checking those immediately after the presentation. And I'll also be looking at it throughout the day. And if you have stuff come up later, feel free to shoot me an email. I found that if you have a question, other people probably do too. So thank you very much for hanging out with me, and enjoy the rest of Stir Trek.